Chapter 14, Minitab Express. Using the textbook dataset, answer the following questions. Researchers continuously try to understand why people do or do not vote in elections. Using the dataset, examine the relationship between the dependent variable percent of the population voting and two independent variables of your choice representing education, poverty, unemployment, crime, or income. Use interval data. Write a hypothesis about the relationship between the dependent variable and each independent variable. Remember to indicate an anticipated direction. I will work with the variable percent of population voting, C27, and SAT grand total located in column C21. My hypotheses are: research hypothesis H1, as the SAT scores increase, the percent of population voting will increase. HO, null hypothesis, there is no relationship between SAT scores and percent of population voting. Create a scatter plot for each relationship. Do the data fit a linear model? Explain why or why not. For the scatter plot, we use graph, scatter plot, simple. Select the y and x variables, and I will do percent of population voting as my y variable, and the SAT scores, which is in C21, as my x variable. Here's the scatter plot. The scatter plot seems to show that the percent of the population voting does increase with the SAT score. The relationship does appear to be linear. Obtain the following statistics for each relationship: the constant, slope, or regression coefficient R, standard error of the slope. To find the constant, slope, etc. in Minitab Express, we use statistics, regression, simple regression. Enter the response variable, which is the percent of population voting, the predictor variable. You don't need the options or the graph tab. Here's the output. The correlation coefficient, remember we saw a positive relationship, so the correlation coefficient is going to be the square root of r squared, and my r squared is right here, so it's 0.0784. Take the square root of that and we get 0.28. We can also calculate the correlation coefficient using the command statistics, correlation, select the two variables, and there's my correlation coefficient. Write the regression equation for the relationship. The regression equation appears at the bottom of the regression output. How well is each relationship described by the linear regression model? Cite evidence to support your observation. Use the regression output to answer this question. For each relationship, decide whether or not it supports the hypotheses you wrote. Use the regression output and scatter plot to answer this question. Question 2. Use the variables in the dataset to create and test a multiple regression model of your design. Write a linear model that includes 4 to 5 independent variables. Your write-up should suggest the value of studying the relationships and provide evidence supporting the hypothesized direction. My model will use per pupil expenditures located in column C19 as the response variable, and public school final enrollment in C16, public school faculty C17, SAT grand total C21, and mean household income C40 as the independent variables. I will predict the expenditures will have a direct relationship with all 4 independent variables. Test your model and present your findings in a table or equation. To test my model, I use stats, regression, multiple regression, enter the response variable, and I'm using C19, and then enter the predictor variables, C16, C17, C21, and C40. Then click OK. Here's the regression equation right here. Write a verbal description of your findings. If your hypotheses were not supported, suggest possible reasons for lack of support. All the variables were contributing with the exception of the SAT, grand total, and the mean household income. Why? Use the coefficients here to help you answer that question. R squared, 26.6%, tells me that about 27% of the variation in, you fill in the blank, is explained by, you fill in. It is interesting to note that public school final enrollment has a negative coefficient, indicating an inverse relationship with expenditures. Is this what we expected? What does this mean in the context of this model? Please note that for your assignment, you need to use different variables than are shown in this demonstration.